Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. Today we're going to be jumping into an 8th grade topic, graphing functions. Now, if you have any questions about what you see here today, remember you can always put that in the comment box below. But if you'd like to see your own homework on this channel, you can visit me on Facebook at Tutor Me Senpai, and you can tell me all about it there. If you find this video helpful, remember to leave the like. It really helps the channel. And while you're at it, hit the notification bell and the subscribe button so you know exactly when I drop my next videos. Well, without further ado, let's talk a little bit more about graphing some functions. Now, there are a lot of different ways you can graph functions. We'll be talking about 2 today in particular, but before we get into that, I want to discuss some basic functions that you may run into. So the first one being linear functions. The second one, your quadratics. And the third one, your cubics. So the linear functions, they're characterized by a power of x equal to 1. The quadratics are characterized by a power of x equal to 2. And the cubics are characterized by, you guessed it, a power of x equal to 3. Now I want to go over this just so you can have an idea of what these kind of look like. So when you have a linear, the general shape of a linear is going to be a straight line. All right? Straight line. There's no curves. It just goes straight from one end to the other. Don't even have to think about that. A quadratic will look something like this. So you see, it has a definitive top or bottom depending on if it's going up or going down, but everything else kind of goes into infinities, right? So you see for the linears, these kind of keep going both sides, either way, to infinities, where here we have this little bend here, right? So quadratics will tend to look something like this, where linear tend to look something like this. Cubics. Cubics tend to look something like this, or something like that. So I just wanted to show you some general forms that these functions will have based on the different types of functions they are. A linear function will never look like a quadratic. So if you're working with a linear function, you know your function should look like this. So if you're ever graphing a linear and it doesn't look like this, you might have done something wrong. Likewise for a quadratic or a cubic. These are the general shapes. If they don't fit this shape, there might be something wrong with how you graphed it. So use these as a baseline to check your answer. Linears are going to have a max degree of 1. Quadratics will have a max degree of 2. Cubics will have a max degree of 3. Linears like a straight line. Quads have this one bump here. And cubics you see have these 2 bumps here, right? So for today's example, we're going to be focusing on a linear function instead of the quads or the cubics. And I told you that we're going to be going over 2 different methods in order to graph this linear function. The first one being the slope intercept form. So we're going to be using the slope intercept form of a linear function. And what that means is our function should look something like this. Y equals mx plus b, where m is the slope of our function and b is the y-intercept. Now, what is a slope? The slope of your function is just going to be how steep it either increases or decreases. So the steepness of this will be the slope. The steepness of this will be the slope. So the slope is just going to be how fast or how slow your function is growing or decreasing. The y-intercept is what is the y value when x is 0. All right? So whenever x is 0, you're going to intercept the y-axis. Where, when x is 0, do you intercept the y-axis? That's what b is. Okay? So you can easily find y-intercepts with the slope-intercept form because we're going to be plugging 0 for x. So you can easily find that out. And that's one of the beauties of the slope-intercept form. So using the slope-intercept form, we're going to go through our first method of graphing this linear function. So when you have the slope-intercept form in this way, the main point is to solve for both m and b. So let's say you had a very easy example. Y equals 2x plus 1. Something very simple, right? Well, what's your b? Off back, you know that's 1, right? B is going to match up with that, so b is 1. And make sure you take the sign into account because you see here we have mx plus b. If this was a minus 1, well, to get this form here, what does b have to be? Let's say this was a minus 1. In order to have it in this form, mx plus b, what does b have to be? Well, in this case, it would be a negative 1, right? Because a negative times a negative gives us this positive here. So make sure that your b takes into account the sign that's present. Now, what is your m? Well, in this case, the m is going to match up with this 2, right? So how do we use this to graph our function? We know what our slope is. We know what our y-intercept is, right? How do we use this to graph our function? Well, that's easy. First, get your graph, right? And we know that this slope-intercept form is going to give us a way to figure out our y-intercept. And our y-intercept is going to be where x is 0. So this is our x-axis, and this is our y-axis. When x is 0, we know that our y-intercept is going to be 1. So if we go up 1, instead of having that point here, that's not supposed to be there, our point is going to be here, right? At 0, x is 0, y is going to be 1. And you can see that, right? If you was to plug in 0 for this x, that would be 2 times 0 plus 1. And what do you get when you multiply anything by 0? 0. So you're left with y equals 1. So when x is 0, y is 1. Hence, we have 1 point at the point 0, 1. So because of the slope-intercept form, we can easily find 1 point on our graph. Now we can use the slope to find the others. One thing cool about the slope, it doesn't matter if you have a whole number or a fraction. I want you to rewrite the slope in fraction form always. And here's why. What is 2 as a fraction? Well, it has a lot of different forms, right? But the simplest form is just going to be 2 over 1. And the reason why I want you to do this is because this is going to be what we call rise over run, right? Your slope is going to be rise over run. So if you don't have a slope that's a fraction, make it into a fraction. If it's a whole number, just put it over 1. And then this is going to determine your rise over run for your function. Rise simply means how are you going to be going up or down on the y-axis? Run simply means how are you going to be going across on the x-axis? So this says we're going to be going over, since it's a positive 1, over 1 space on the x-axis. So if I was to start from our y-intercept and go over 1 space, that's going to be 1, right? But do I put a point here? No, because that's just focusing on the run. We have to do the rise next. This tells you how far up or down we're going to be going on the y-axis. And because this is positive, we're going to be going up. Just like this positive 1, meaning we go to the right. Because this positive 2, we're going to be going up. So instead of putting our point here, that's going to be 2, that's going to be 3, we're going to be going up here. So now we have 2 points on our graph. And let me tell you something really cool about linear functions. Right here, that's all you need to graph the rest of your function. Remember, they're going to look like this or like this. So if as long as you have 2 points, you can just draw a line that connects them all. Now, forgive me, this is not straight. If you have a ruler, I recommend you do that. But this is going to be the general path because it can't change. It has to be like this or like this. And because we have our 2 points in this fashion, the graph is going to naturally have to be like this. So as long as you have 2 points for a linear function, that's all you need to graph it. So you see here, we use our slope-intercept form to get our first point by finding the y-intercept. Then we use our slope, which we converted to rise over run, to find our second point, and then we connected those. And remember, these are going to keep going because we're not stopping. These linear functions don't stop unless we tell it to. But we're not telling it to, so we're going to just keep going. So now that we talked about graphing our function using the slope-intercept form, let's talk about the second method. This method is just going to be the value form. And I'm going to just call it that because we're going to be finding the values of different points and then figuring out our graph from that. So it's going to be pretty similar to the slope-intercept form because you saw we found points. But what we're going to be doing here is focusing mainly on just evaluating it at random points. It doesn't have to be the y-intercept or anything like that. Just throwing in random points to kind of get an idea of what our function is going to look like. So let's say we start with the same function, y equals 2x plus 1. Our value method is going to say, all right, let's figure out what our x's and our y's are at different points, right? And we're going to be plugging this in and see what we get. We're going to be solving this, okay? So when x is, let's say, -1, what do you get when x is -1? All right, so that's going to be a 2 times -1 plus 1, okay? And what's 2 times -1 plus 1? Well, that's going to be a -2 plus 1 gives us a -1, all right? So that's 1 point. -1, -1. How about when x is 0? Well, x is 0 gives us 2 times 0 plus 1. And that gives us 1, right? So here's our next point. 0, 1. And remember I said you could stop here because all you need is 2 points for a linear function. But let's go one more. Remember, you're just plugging this in. 2 times 1, 2 plus 1, 3. So if we were to then take these 3 points and graph them, all right, so we're going to have a -1 for x, we're going to have a 0, and we're going to have a 1, right? And we're going to have a -1, we're going to have a 1, and we're going to have a 3 up here. And this is the y-axis, this is the x-axis, right? So graphing our first point, we get -1, -1, so that looks like this down here, right? Boom. Going back -1, over -1, here we go. Next point is going to be 0, 1, so we put something here. The next point is going to be 1, 3, so we put something here. So now you see the general pattern that our function is going to be looking like, right? And because we know linear is always like this, we can just connect all the dots and go up into infinity. And down to -infinity. Just keep it going. And now you've graphed your function once again, using the values at different points. Now we didn't have to use -1, 0, 1. You could have gone up 10, you could have gone back -100. It doesn't matter. Linear functions, remember, they're always going to follow the same path. And as long as you have 2, you can figure out how your graph looks. Here's a little extra nugget for you. Before we move on to our question, I want to explain the differences between these two. One's a function and one's not. Could you guess which one is a function just by looking at these? Exactly. This is a function. This is not a function. But you can graph them either way. But I don't want you to get confused when you're dealing with these. So whenever you have a y equal a constant, well, constants always are constant. They don't change. They're pretty much like linear functions, except they don't go up or down. They are just constantly going across. So they are purely horizontal. So if you was to graph this y equals 3, that's pretty much saying no matter what value of x you get, y is always going to be 3. So if you have a 3 here, y is just going to be 3. So it almost looks like another x-axis, right? So it's important to label those, but this is y equal 3, okay? Y equal 3 is a function. It passes our vertical line test. It's a function. However, x equal 3 is not a function. And it looks a little bit different. So, similar to how this says for every x, we're always going to have y equal to 3. This is saying for every y, we're always going to have x equal to 3. So, it's going to look like this. Now forgive my shaky hand, I don't have a ruler, but you notice that it doesn't matter what your y is, right? Y can be 100 up here, y can be negative 1,000 down here. It doesn't matter. X is always going to be 3, but this epically fails the vertical line test. Hence, it's not a function. So if you're ever asked to graph these type of functions, well, notice this is not a function. So if they're talking about functions, it's most likely going to be something like this. And if it's like this, you know that's going to be purely horizontal, whereas this is going to be purely vertical. So try not to get confused with these. Although they look very similar, they're very different. One's a function and one is not. So now that we've talked about all of that, let's put everything into practice and solve our question for today. So we have our function f of x equal negative 3 plus 3x. Now, I want us to use the slope-intercept form here. But I recommend you take your time and use the other method we talked about, the value method, to check your work. Make sure you can get the same answer both times. So the reason why I want us to do the slope-intercept form here is because it doesn't necessarily look exactly like the slope-intercept form. So I want to show you how to manipulate this to get something like this, right? Now, it's not much you need to do. It's simply a rearrangement. But whenever you have this function here, that's pretty much synonymous with this y. So you can change this to a y, okay? And here we have this mx. Well, anything here attached to an x? Yeah, this. So let's write it up front, just so we can get it in this form, so we don't have any questions. So it's going to be y equals 3x. And then we have this plus b. Well, that's just a constant, right? So we're going to move our constant to the end. But we're going to keep the sign. So now we have something that's in this slope-intercept form here. So now the next thing we want to do is figure out what our m is and what is our b. Well, m is going to be 3. And then b is going to be, remember, I want you to keep the sign. Because if we're going to get this positive b here, what does b have to be? Negative 3, right? If we were trying to get it exactly the same, b would have to be negative 3. Therefore, by plugging all this in into our slope-intercept form, we get this back. So now that we figured out our m and our b, how can we rewrite this slope? Remember, I wanted to try to get something like a rise over run. So we're going to change this 3 to be 3 over 1. It's the same thing, but we write it in fraction form because this is going to be our rise over run. Rise over run. And remember, rise is going to be how far you're going up or down the y-axis. Run is going to be how far you're going across the x-axis. So now we have all of our players. So let's draw our graph. And this B tells us our y-intercept. So this point is pretty much 0, -3. Because our y-intercept is what do we get when we plug in 0 for x? We're going to be left with this constant here. So 0 for x gives us a -3, our y-intercept. So let's graph that first. If this is 0, we're going to be going down to 1, 2, 3. This is -3. And we're going to put our point there. Next, let's use our rise over run, our slope, to figure out what our next point is going to look like. So this run tells us we're going to be going over 1, and that's it. So I'm going to space this out a little bit more. 1, right? So we go over 1, but we're going to go up 3, because this is all positive. So we're going to go up 3. So if we go over 1, right? Going up 3 goes 1, 2, 3. So now we're on the x-axis here. And remember I said for a linear equation, which is linear, right? Because understood exponent of 1, we only need 2 points. So now we know how our function is going to look. We can simply connect the dots. And this is going to go to infinity, that's to -infinity. This is the x-axis, this is the y-axis. And now you've graphed your function. Well, I hope you're able to follow along with today's example. But if you had any questions, remember you can always put them in the comment box below. Or if you have any questions about your own homework you'd like to see on this channel, visit me on Facebook at Tutor Me Sempai. If you found this video helpful, remember to leave a like. It really helps the channel. And while you're at it, hit the notification bell and smash the subscribe button so you know exactly when I drop my next videos. And share the video too, if you think it might be helpful for somebody else to know. Well, that's all the time I have for today. I really hope this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.